and Dr. Lin will be talking about projected urban expansion over eastern China. Please take it away.
Okay. Hello, everyone. My name is Lin Pei. I am from Institute of Urban Meteorology in Beijing. My topic here today is the projected urban expansion over the three vast urban agglomerations in China and the associated influence on regional climate. And my co-authors are Professor Shiguang Miao, Professor Xiangyu Huang, and Professor Deliang Chen. And then come to the outline of my presentation. The first one is the introduction. And as we can see from this picture that we all know that urbanization have some inevitable influence on the regional climate change. And because of the increasing person are living in the urban area, so the urban climate change are very important. And comes to China. During the past decades, China has experienced the rapid urbanization and resulting in large increase of urban surface area changes. And such expansion have contributed to inevitable influence on regional climate change. And some methods are used to quantify the associated effects, such as urban minus rural observations and the GCM attribution analysis. And most of them are used the high-resolution regional climate model to do the experiment to quantify the urban expansion effects on regional climate changes. And there are some papers published in papers and project the urban expansion data set. And this is the first one published by Settle in 2012. And they indicate that urban land cover would increase by 1.2 million square kilometers by 2070s, nearly tripling the current situations. And this paper have used this data set and performed the WORF model with urban canopy to have a 20 kilometer resolution for 3 years to quantify the impacts of urban expansion in China. And they found that extensive warming up to maybe 5 degrees and 3 degrees and 2 degrees under different urban growth scenarios, and a significant moisture defect. And in the extreme scenario, they will project that the large-scale precipitation will be decreased significantly. And then several high-resolution urban expansion datasets have been published. Here is the list by the different papers. And we can see that caused by the different land cover changes data and the different growth model and the different treatment of the relationship between the urban areas and the social economic indicators. The special pattern of projected urban expansion obtained by different published papers shows large discrepancies. Here come to the global scale. Caused by the declining urban population and the increasing GDP, and the different papers projected different urban growth ratio over the global scale. And come to the country scale, we analyze the China, USA, India, and Nigeria. And we found that the different data set shows the different urban growth ratio, especially in China, caused by the urban population decline. Some paper even project the slow and decreasing urban growth ratio. Then come to the key question of my talk. The first one is, how about the urban land expansion will be changed in the future in China? And the second one is, how about the effects of the projected urban expansion on regional climate change over China clusters? We want to perform and propose a proper assessment of how future urban changes over China and promote analysis of the associated climate effects, which is very important to elevate the social and environmental problems that will challenging the sustainable development of society. Here is outline of my results. The first one is the projected urban expansion in China. This figure we have proposed earlier, and in detail, we found that the regions of these differences, the first one is the different historical urban land use data, and the second one is the different historical social economic factors. And the third one is the different urban growth model. Some are use the slash model, and some are the flats, and some the large urban and the different. And I think the last is the most important factor. That is, they use the total GDP or the per GDP of each person. It is very important because the population will be declining. This is important. And come to the regions, we concentrate on the three urban clusters in China, which is the first one is the Beijing Tianjin Hebei region in the higher altitude, and the second one is the Yangtze River Delta that is in the middle latitude, and the last one is the Pure River Delta that is in the lower altitude. And we found that the different data sets shows the different spatial pattern of urban land use data, and the raw resolution is different, such as the last one, the Gao data is closer, and the expansion is very large. Here is the statistic analysis of these regions, and the resolution is 3 kilometers, which is consistent to the following WRF models. And we found that the He dataset is expansion very slow, and the Li dataset is expansion fast, and the Chen dataset is relatively slow, and the Gao is extremely fast. And in my opinion, I think it's unrealistic. And then we use the WRF model and coupled with urban canopy to perform the 4 simulations, and each is 5 summers, and we concentrate on the slow urban growth ratio and the fast. Here is the spatial pattern of the air temperature simulated. We found that comparing to the driving condition, that is ERFL reanalysis, our WRF model have simulated reasonable spatial pattern of air temperature and a clearly characteristic of urban heat island, and the time series we simulate is reasonable. Then come to the changes, and this is the bottom line is the changes. We found that the projected urban expansion has contributed to an extensive warming, but for the different regions, such as in the lower altitude over the Pure River Delta, it is insensitive to fast urban expansion, but to the higher altitude regions, such as in the Beijing and in Shanghai, it is very sensitive. And this is for the urbanized cell, that is the T average, T max, and T mean. And we found that predominantly nightmare warming, that is the T mean. And interesting that as the same to the following, the former analysis, the Pure River data, it is very insensitive to the different urban growth. Here is the statistics analysis. And we have also do some deeper analysis of the mechanism. Here is my explanation. I think the different climate background is very important to this phenomenon, maybe constrained by the relative humidity over this lower altitude. It's very humidity in this area, so it is insensitive to the very fast urban growth. Here come to the take-home messages we have mentioned above. That is, the future and the projected urban expansion is various based on the different data sets. And for some regions, maybe even for the same region over Eastern China, but it's a different altitude that will influence the response to the different urban growth ratio. And we will do a deeper analysis. And we also want to introduce the urban climate analysis in Institute of Urban Meteorology in Beijing. We want to concentrate on the Eastern China that is the most urban located. And we want to perform a kilometer resolution urban climate surveys, such as the urban climate prediction. We want to use the WRF as a tool to make the dynamic downscaling, maybe 9 kilometers over the main China. And we also, based on the ensemble of GCMs, we perform a lot of attribution and projection of extreme events over the city. And we have also some published paper in this area. And we also want to make assessment of urban adaptation of the mitigation measures. And this is the example of the ventilation corridors in Beijing. We also use the WRF model to quantify the influence of such mitigation measures. That's all. Thank you. And questions and comments are welcome.
We have time for several questions. Well, let's say 2 or 3 questions.
Maybe I can ask. The first one is exact temperature.
Hold on a second.
Okay. That's wrong. And the exact temperature, have you see some kind of wind field, such as velocity, temperature, and turbulent intensity, this kind of data. And the second one is the WRF model and the urban canopy model. Actually, in my opinion, the urban canopy model kind of not exactly following the physical process in the urban canopy. So do you think the urban canopy model is exactly the true model can be used in WRF? And this kind of urban canopy model, whether this kind of urban canopy model can affect some negative effect to the final results? So what's your opinion and what's your comments on this?
Okay, thank you for your question. The first one, that is, we also analyze the other meteorological elements and variables caused by the urban land cover changes, and we will talk later. And the second one, I think it is very important to improve the simulations by WRF. And we in our research, we just use a single layer. The single, it is very simple because we have to do the long-term running. If we use very complicated urban model, it will cost our computer resources. But when we have enough or lots of resources, I think it is very important to improve the WRF model. Thank you.
We have time for one more question.
I can ask. Yeah.
Thank you.
So I have a question interested in your future prediction on cities. I just wonder, in your simulation, which factor are you consider? You just consider the city area expanding, or you also consider the urban structure change, or also we can say in future maybe the anthropogenic it release will change. So which factor you have been considering in your simulation?
This is very preliminary plan, and from now on, we just take the urban expansion. Yeah, maybe later we will consider more elements.
Yeah.
Thank you.
Thank you.
So next up is Professor Andreas Christian, and he will be talking about urban-rural, intra-urban variability of mixed layer heights in Berlin, Germany.